Marcelino. Marcelino can't do anything. He just tells me to text other people.
What's up, guys? This is Colbert. This is the Chapter 5 unit video. Okay, so to start it off, we're going to be going through roots and rational expressions. This whole lesson covers a lot of exponents, so we're just going to do a quick little review. Exponents are like 2 squared, 2 cubed, 2 to the power of 4. So yeah, let's do 2 to the power of 4. Pretty much, what you'd be doing, it's pretty much 2 times 2 times 2 times 2. 4 2's. So, what I like to do sometimes, usually I use this for larger ones, but this is easier, but here's just an example. 2 times 2 is obviously 4. Then we multiply these two together. 4 squared is 16. So that's just an example. For this one, you will see that it's a fraction right here. So the trick is to take the number on the bottom of the line, put it on the inside as a radical with 32. You gotta take the top one and put it on the outside of the parentheses. What you do, you find the fifth root of 32. It's gonna be 2. Then you square that. Get 4, obviously. Now, for this one, it's almost going to be the same thing, but you know it's going to be a negative. Therefore, we might have 2 answers. Do the same thing, you put 3 on the inside with the radical, then you have the 5 on the outside. We came up with 2 to the 5th because of the 5th, or negative 2 to the 5th. Therefore, I got negative 32 or positive 32. Alright, so now we come to our properties and products. Alright, right here is power of power. Pretty much it's just an exponent of the base and its exponent. So for example, I have 2 to the 4th squared, as you can see on the outside of the parentheses. Now we're going to use order of operations with PEMDAS which means parentheses is going to be first. That's what I at least do. I find it easier. So 4 times 2 times 2 is 4. I already have 4 down here. 4 times 4 is 16. We're gonna take the exponent 2, bring it to 16, and the square root of 16, or not the square root. 16 squared is 256. Moving on, we have the product of a power. 5 squared times 4 is 6. Alright, what you're going to be doing, the only things you're actually going to be multiplying in this multiplication equation is 5 and 4, so we have 20 already. Why do we have 8? Obviously, we just added 2 and 6. Simple as that. Now we come into negative exponents. Now 8 with negative 2 squared, negative 2 for its square. A lot of people have problems with this. I don't have a notebook at the moment, so I had to do a little research on ways to solve this kind of thing. So what I found is that since it's an integer, it's going to be the opposite of a regular number. So it's going, instead of doing multiplication process, like 8 times 8, it's going to be almost a division process. So what I have here, 8 to the negative 2 is equal to 2 divided by 8. We have 2 over 8, and we have 0.25, which is equivalent to 1 over 4. A quarter is a quarter. Next we have the zero exponents. Pretty much the whole dealio with the zero exponents is that whenever there's an exponent with 0 as 0, it's just going to be 1. So it could be 5 to the 0, it's going to be 1. 2 to the 0, it's going to be 1. X to the 0, it's going to be 1. X to the 0 times 5 to the 0 times 8 to the 0 times 100 to the 0, it's going to be 1, bud. Alright. So now we have the quotient of power. Pretty much the whole deal is it's almost going to be like right here, the product of power, except it's division. Therefore, since we're adding up here, down here we're going to be subtracting. So it's 10 divided by 5. So 7 minus 2 is going to be 5. and 10 divided by 5 is 2, obviously. We all got that. Cool. For the quotient property, it's a lot simpler than you think with all this work. We have the radical of 49 over 4. Now, when you really break it down, 49 is just 7 times 7, and 4 is just 2 times 2. Therefore, we can just break that down into 7 over 2 squared, which is equivalent to 7 over 2. 7 is the square root of 49, and 2 is the square root of 4. So we can just have a radical 49 over radical 4. Therefore, 49 over 4 is equal to radical 49 over radical 4. The whole rule to that is, a being the numerator, or the number on top, has to be, in order for this to work, it has to be greater than or equal to 0, and d has to be greater than 0. For our last one, it's going to be a product of properties. Now for this one, let's take 36 for example. Square root of 36 is going to be 6. So we could just break down 36 as 4 times 9, and 6 as 2 times 3. 2 is going to be the square root of 4. 3 is going to be square root of 9. Thus, square root of 4 times square root of 9. Pretty much that's what it equals. I hope you got that. Look at that hang time right there. I think we could make an equation out of this. Alright. So hang time is the time one is suspended in the air for. Hang time, t, in seconds, is given by the function t equals 0.5 radical h, or height, where h is the height in feet of the jump. If Michael Jordan is in the air for 1.5 seconds, what is the height? What would the second height be if you doubled the time to be 3 seconds? Alright, what we're going to do, we have 1.5 over 0.5. It's a division process, but obviously the decimals are making it a little harder. So what you can totally do is move the decimal point one time back, just to make it regular 5 and then 15. Therefore it's going to be 15 divided by 5 equals 3. 3 is going to be used to find the height. So we're going to square. Let me focus it. There we go. We're going to square 3. We're going to get 9. 9 equals the height in feet. But that's only for the first height as the base. We're going to do the same thing with 3, since 1.5 times 2 is 3. We're doubling it. We're going to do the same thing, bring back the decimal. It's going to be 30 over 5. That equals 6. Square 6, 36. 36 is the height in feet. That's how you figure out a hang time equation like that. Pretty simple. Alright. So, over reflection of this year and your classmates at Suzu, I feel like I've been slacking off, honestly. I've been putting videos off, and I feel bad because I thought, oh, this is going to be MCR, it's going to be slower, it's going to be easier. I totally just kind of f***ed in this class, and I have a pretty bad grade. I'm definitely being honest. I don't care how many people see this. That's my fault. Honestly, what I want to do, and what I have done over this lesson, Chapter 5 was really easy, and I think I made it easier just by paying attention more and taking more notes and being more proactive in my work. I feel like I can really do good on this test soon when it comes up, and I'm proud of what I've been doing. This video is a lot more informational than how I've usually been making it, and I wanted to make you proud, Mrs. Sue. Not only you, but myself as well. Yeah. Through the otter, lion, golden retriever, and the beaver thing, honestly, I think I would be an otter, because I can find myself being pretty oblivious on some things, but when I really want to put my mind to it, something I really want to do, I go ahead and do it. And that's what I got out of the otter when you brought it up. I could be a good listener like a golden retriever, anything like that, but the otter really kind of defines me as one who's more expressive, one who is more jumping out and doing stuff. I could be a lion in some situations where I can be a leader, but mostly I'm an unorganized freak, but I still want to get stuff done. and I'm gonna have to fix some small details about that if I want to prevail in life. Yeah, love languages. Love languages. The video you showed us was, I thought that was really beautiful. It gave me goosebumps when I watched it. It really helps you connect with anybody you want to build a relationship with. Always know how they're feeling. Always try to do stuff for them to make them feel better. Be a giver, not a taker. And use communication through many different ways. Through physical touch, whatever's comfortable, obviously, and through words. Not just any old words. Words that's really going to connect to your significant other and make them feel better about how they feel about you. Thank you, Mr. Suhu. I hope that I can do better in this class, and I really think this video is a marking point. Thanks for watching. Christmas, Mr. Suhu!